So this is the next part of the video on the 6-7, I'm sorry, 6-6 and 6-7 practice mini test that you guys are going to take in class before I get back next week. I believe you're taking it in class either Thursday or Friday of this week. Anywho, let's see. So we're on question number 5. So it says solve and check for extraneous solutions. This is because sometimes weird things happen when we plug an x back into a log equation. It's because we can't take the log of anything less than anything 0 or less. So sometimes we get a solution that works mathematically, but not when we plug it back in. So we just have to be careful of that. So this first one's pretty straightforward. Log natural of something equals log natural of something else. Because there's nothing else happening, since we have log natural of one value equals the log natural of a different value, we know these two values must be the same. So I can just write a statement of equality that says 4x equals 7x minus 9. And now I solve for x. So I'm going to subtract 4x and add 9 to both sides. So I get 9 equals 3x. Divide by 3, x equals 3. If I plug that in, I get log natural of 12 equals log natural of 21 minus 9 is 12. And that's a good check because we can take the log natural of a number like 12. This number is not particularly nice, but it's a real number and that's all that matters, and that it equals itself. Number 6, we have log base 5 of something with a variable equals 2. Again, I can't really get to this because I can't find the value of this variable while it's wrapped up in the log. So what I need to do is I need to rewrite this as an exponent because it doesn't equal a log over here, right? So if I write this as an exponent, it's pretty nice. Log base 5 of this equals 2. So I'm just going to whale it and get 5 to the power of 2 equals x plus 1. And from here, it's pretty straightforward. 5 squared is 25. I subtract 1 from each side, and I get x is 24. If I plug that in, 24 plus 1 is 25. Log base 5 of 25 is 2, and 2 equals 2. So that's a really nice check. This log equation is a little bit messier because we have two separate log expressions which are being added and they equal 4. So if I were to add one log expression to the other side, I'd still have this 4 to contend with. So it wouldn't be as easy as just saying this equals this because the 4 is in the way. So what I want to look at is notice that these are both base 2, which means I have the option of writing them as a single log. So I'm using the log property that says log of nm equals log of n plus log of m. So in other words, I can put these two expressions and write them as a single log of the product of those values. So log base 2 of 2x times x minus 7 equals 4. And now I'm going to just kind of clean that up a little bit. So that's 2x squared minus 14x. And now that I have log with a base of something equals something, I can go ahead and rewrite that as an exponential. So when I do that, I get 2 to the 4th is 2x squared minus 14x. That is a 16. So I'm going to subtract 16 because I have a quadratic here, so I want to set it equal to 0. And I'm noticing that all these numbers are even, so I can go ahead and divide them all by 2, because 0 divided by 2 is still 0. And because this is a quadratic, I want to factor to solve. So factors of 8 with a difference of 7 are 8 and 1, and because this is a minus 7, it's x minus 8 and x plus 1. So if I FOIL this together, my middle term is a minus 7, and my constant term is a minus 8. So if I set each factor equal to 0, I have x is 8 and x is negative 1. Now, one of these is probably going to be extraneous. So if I look back up here, if I plug in the 8, that's a 16, that's a 1, that's great. I can take the log of 16 and the log of 1. But if I plug in a negative 1, that's a negative 2, that's a negative 8, and that doesn't work mathematically. So that means that this answer is extraneous, while x equals 8 is a valid answer.